Let's begin here. This frame originates from December 19th, taken live from Chuck's astrophotography utilizing Starfront's 24-inch telescope. At first glance, it appears serene, a compact glow, a soft envelope, nothing particularly striking. However, a closer inspection of the geometry reveals the central region remains tight and well-defined. While the surrounding haze extends unevenly in one direction, it does not expand symmetrically, nor smear with the stars. The object maintains its shape, while the background indicates that the mount is functioning precisely as it should. This is significant because larger apertures do not tolerate mistakes. A 24-inch system amplifies tracking inaccuracies, seeing problems, and processing artifacts. If something presents itself clearly here, it's not by chance. What we're observing is a consistently directed structure that is already recognizable from smaller telescopes. Now verified again at significantly higher resolving power. This serves as our baseline. Now, let's analyze each image one by one and see what varies and, more crucially, what remains unchanged. Next, let's shift to this image. Captured on December 19th by Ivan Vasquez at Calopa Stars using a C-Star S50. It is a considerably smaller consumer-grade system in comparison to the 24-inch telescope we just examined. And that contrast is the crux of the matter. Despite the shorter 2-minute stack of 10-second exposures, the object does not dissolve into noise. The core remains compact, and the surrounding glow is not circular. It subtly extends in the same general direction observed in the larger telescope's data. Note what is absent here. The stars maintain their roundness, there is no smearing due to poor tracking, and no excessive processing extracting shapes from nothing. Nevertheless, the object itself continues to exhibit an elongated inner structure even at this scale. This is significant because smaller telescopes are unforgiving in a different manner. If a feature persists despite limited exposure, time, and modest optics, it is not merely something that appears under extreme processing or with larger apertures. What we are witnessing is behavior independent of scale. Large telescope, small telescope, the same narrative. Let's proceed down now. Take a look at this follow-up image from the same observer. This frame is a 15 to 16 minute stack still from the C-Star S50, taken later that same night on December 19th. With increased integration time, something crucial occurs. The object doesn't merely become brighter, it grows more defined. You can distinctly see the inner region elongating into a narrow shape with a brighter condensation at one end, and a softer extension trailing away from it. The surrounding glow is not symmetric, it features a preferred axis. Meanwhile, the background stars convey a different message. They remain round, free from smearing or stretching in any direction, which eliminates possibilities like wind, shake, poor tracking, or stacking errors. What this frame contributes is temporal reinforcement, same instrument, same night, longer exposure, same orientation. If this were mere noise or a processing illusion, longer stacking would obscure it. Instead, it sharpens. That's the pattern we continue to observe. Let's continue. Now, we travel to Italy. This image, captured by Tony Scarato on December 18th using a 25 cm Newtonian telescope, is not casual imaging. It involves a long, meticulously stacked sequence with known resolution, pixel scale, and field orientation. First, examine the raw wide field. The background stars are streaking. This signifies that the telescope is tracking the object itself, not the sky. Directly at the center, 3I Atlas remains tight. Now compare it to the resampled close-up on the right. The inner coma is no longer circular. It has taken on an elongated form with a clear axis running at approximately PA. That's a specific, measurable direction, not just a vague blur. The central condensation is sharply defined, while the outer coma expands into a broad greenish envelope that is estimated to be hundreds of thousands of kilometers across. What's important here isn't solely the shape, it's the internal structure within that shape. You have a compact central core, an elongated inner region, and a larger asymmetric outer coma. That constitutes a layered system. Once again, the elongation corresponds with what has already been documented from smaller instruments, across different continents, and on different nights. Diverse telescope, different processing, yet the same directional behavior. That consistency is performing the heavy lifting here. Let's continue. Next, we arrive in New Zealand. This frame was captured by Brian Dietrich on December 17th using a 203mm Schmidt with short exposures, minimal processing, and clean tracking. It initially appears subdued, a faint object without striking flares or an obvious tail. Yet, this is the point. The central condensation remains compact, no smearing, and no breakup. The surrounding glow is not arbitrary, but slightly biased in one direction. Now, examine the inset. This is an enhanced view of the same date and nothing added. Nothing painted in. Once more, the inner structure does not collapse into noise. It holds intact. Here's the significance of this. When an object is this faint, processing artifacts typically take over, edges become uneven, centers shift, and shapes dissolve. That is not the case here. Instead, The core remains solid while the surrounding material reveals the same preferred orientation we have seen from Italy and Hawaii. Different hemisphere, different telescope, different night, yet the same behavior. At this stage, the pattern isn't originating from a single setup or observer. It is derived from the object itself. Let's keep stacking the evidence. Now, we completely shift off Earth. This image is not sourced from an amateur telescope or even a ground-based observatory. It originates from NASA's Europa Clipper spacecraft, utilizing its ultraviolet spectrograph captured on November 6, approximately 164 million kilometers away. What you see here isn't a photograph in the traditional sense. It's a composite intensity map plotted in ecliptic longitude and latitude that illustrates where ultraviolet emission is concentrated as the instrument scanned the sky. That bright blue Area 3 atlas shows something notable. The emission isn't spherical or symmetric. It's elongated in a preferred direction within a broader diffuse structure, even at ultraviolet wavelengths. From interplanetary space, and through a completely different observing method, the geometry remains consistent. This is significant because UV instruments are indifferent to dusttails or aesthetic optics. They are responsive to gas, excitation, and interaction with solar radiation. Thus, when a directional structure appears here, it is neither a camera artifact, a stacking trick, nor artificial contrast. It is physical. By now, we have maintained the same orientation appearing in raw optical frames, RGB channel separations, long-time series stacks, and ultraviolet spectroscopy from a spacecraft millions of kilometers away. Different physics, same alignment. At this juncture, it can no longer be considered coincidence. It's a behavior. Whatever is driving this remains active. In conclusion, across various nights, different telescopes, different continents, and even from a spacecraft, 3I Atlas consistently displays the same characteristics: a compact core and a directional structure that refuses to fade, rotate erratically, or break apart. This is not a phenomenon resulting from a solitary observer, nor from a single filter, nor does it only emerge after intense processing. Whatever is responsible for this behavior is stable, persistent, and real. The question now isn't whether the structure exists, but rather why it maintains such clarity and why it is appearing so distinctly right now. Is this a jet driven by localized activity, a geometrical effect we are observing from the ideal angle, or something about interstellar matter behaving unexpectedly? Share your thoughts in the comments. If you'd like the latest updates as soon as new images arrive, please like the video, subscribe, and share this with someone who has been following the 3I Atlas story. We're not finished with this object.